In the world of AI, there's one thing that gets everyone's attention: anything that promises to cut costs. But that begs the question, why is AI so expensive in the first place? Well, today, we're going to dig into that exact challenge and look at two really interesting new tools that are tackling the problem from completely different angles.
So yeah, what's the deal with the cost? It really all boils down to the insane amount of computational power and data you need to run these sophisticated models. And that cost, it's not just a number on a spreadsheet. It's a real bottleneck for innovation. It's a huge hurdle for anyone trying to scale up a new idea. So the big question is, how do we get past it?
Okay, our first solution hits the problem before the data even makes it to the AI. It's all about making the information we're sending way leaner and more efficient right from the get-go. Let's check out this clever new format called Tune. So what is Tune? It stands for Token-Oriented Object Notation, and its whole mission is pretty simple: be a super compact data format that just slashes the number of tokens you need to process data. Honestly, you can think of it like putting your data on a diet. It makes it cheaper and way faster for these large language models to read. And the results? They are seriously impressive. We're talking an average of a 64% size reduction compared to JSON, which is pretty much the standard out there. What's so amazing about this is that you get this huge leap in efficiency from what's a relatively simple change in how the data is structured. It just goes to show you how much low-hanging fruit is still out there for optimizing how we do AI. Let's actually see what this looks like. So on the left, you've got your standard product catalog in JSON. See all those repeated keys, the brackets, the quotes. It's really wordy because it has to describe itself with every single item. Now look to the right. That's the exact same data, but in Tune format. It's so much cleaner, right? It almost looks like a CSV file, using this header-based style that's both super compact and, believe it or not, still pretty easy for a human to read. And this slide really breaks down the impact. The original JSON data was 322 bytes, which works out to about 37 tokens. But the Tune version, just 110 bytes. And get this, only 6 tokens. And that token count is the really crucial part, because in the world of LLMs, tokens are what you pay for. I mean, just look at the difference here. The huge bar for JSON next to that tiny little bar for Tune. Now, imagine you're processing millions of requests. That difference right there translates directly into massive cost savings, lower latency, and less GPU usage. It's just a win on every single front. For this one product catalog example, the space saving was a whopping 65.8%. Just think about that. That's a 2/3 reduction just by switching up the data format. It's an unbelievably simple fix for such a massive payoff. Okay, but does this hold up with something more complex, something from the real world? Let's look at e-commerce order data. Here, the original JSON file was around 273 tokens. After converting it to Tune, it dropped to just 120 tokens. That's a 56% reduction. And what that means for you is you can cram more information into the model's context window, and you get your answers back faster, which is absolutely critical for any kind of real-time application. Now, we've got to keep a balanced view here. Tuna is fantastic, but it's not a silver bullet for everything. As the source material points out, for really long, complex data, think like code repositories, it can sometimes sacrifice a little bit of quality and accuracy. But for tabular data, it's an absolute game changer. All right, so we've sorted out the data. Now let's move up the stack and look at the model's architecture itself. This is where Apple has introduced something really fascinating, a new framework called CLaRa. And it's designed to solve a much more complex problem in how AI models actually reason. So to really get what CLaRa does, we first need to understand a really popular technique called RAG, which stands for Retrieval-Augmented Generation. Basically, this is where you give a model access to your own data, like an external knowledge base, so it can pull in relevant facts to give you better, more accurate, and up-to-date answers. It's a super powerful way to make models smarter without having to retrain them from the ground up. But traditional RAG has a fundamental flaw. The system is split into two parts that don't really talk to each other very well. The retriever part just grabs documents based on simple keyword matching, and then the generator part uses them to create an answer. The problem is, the retriever never gets any feedback on whether it picked the right documents. It's kind of like having a research assistant who brings you a giant pile of books, but never learns which ones were actually useful for the paper you were writing. And this is the exact problem that Apple's CLRA, which stands for Continuous Latent Reasoning, is designed to fix.
It's a unified framework that actually builds a bridge between the retriever and the generator, letting them learn together as one single cohesive system. This quote from the source material just sums it up perfectly. With CLaRa, the system learns to pick documents that actually help answer the question, not just the ones that happen to share a few keywords. It's a huge shift from simple matching to genuine comprehension.
So how does it pull this off? Well, instead of just passing around raw text, CLaRa converts documents into these compact memory tokens that live in a shared space with the user's query. You can think of it like it's creating a highly compressed summary of each document that the entire system can understand. And this is what allows feedback from the final answer to flow all the way back to the retriever, which lets the whole system learn and get better together.
So there you have it. We've got Tune, which is optimizing the data coming in, and we've got CLaRa, which is optimizing how the model reasons with that data. Together, they represent this powerful two-pronged attack on AI inefficiency that's happening all across the entire stack. This table really gives us a great side-by-side. You've got Tune, operating at the data layer, solving the problem of bloated data to cut API costs and speed everything up. And then you have CLaRa, operating at the model layer, fixing inefficient reasoning to make the answers more accurate and relevant. Two totally different problems, but one shared goal, making AI smarter and cheaper.
And really, that's the big takeaway here. This push for efficiency isn't just happening in one little corner. It's happening everywhere, from the most basic way we format our data to the most sophisticated architecture of the models themselves. And this, ultimately, is what's going to make AI more powerful, more accessible, and more scalable for everybody.
So this brings us to what's next. As these kinds of efficiency gains keep stacking up, it just opens up a whole new world of possibilities for what AI can do, and, just as important, who gets to build with it.
Which leaves us with this final thought to chew on. We've spent years making AI more powerful and more capable, but maybe, just maybe, the next great leap forward isn't about making it smarter, but about making that intelligence radically more affordable and accessible. Is cost the final barrier to a truly ubiquitous AI? Definitely something to think about. Thanks for joining us for this explainer.